Hi guys, welcome to 6.3 graphing the sine and cosine functions. Let's start with graphing the sine function. What I did is I created the table of values here for you, so we wouldn't need to take the time to do this, but I'm sure that you can all find those function values given these inputs. If you notice, the inputs are our common angles, that is our multiples of pi over 6, pi over 4, and pi over 3, and pi over 2. So those are all our basic angles. One thing to take note of, by definition, the sine is the y coordinate where the terminal side of the angle intersects the unit circle. And if we're on the unit circle, the y coordinate never exceeds 1 or falls below -1. So I know that the range will never go above 1 and never go below -1. And I just chose to put 1 and -1 out here stretched out so we can see the features of the graph, as opposed to doing it tiny squished in here. We can identify the axis however we want. All right, so now let's look at our inputs and plot our outputs. So actually, let's put some angles on these axes. I'm gonna first look at our multiples of pi. So here's pi. I went out 12 units, there's pi. I went out another 12 units, there's 2 pi. So this will be one complete rotation of our unit circle. Halfway between pi and 0 is going to be pi over 2. And halfway between pi and 2 pi is 3 pi over 2. So 90 degrees, 180, 270, 360. Now this gets a little bit trickier. I'm going to look at my multiples of 45 degrees, because those are halfway in between 0 and 90, or 0 and pi over 2. So halfway here, this is going to be pi over 4. Halfway between pi over 2 and pi is 3 pi over 4. Halfway between pi and 3 pi over 2 is 5 pi over 4. And halfway between 3 pi over 2 and 2 pi is 7 pi over 4. So here's all my multiples of 45. 45, 90, 135, 180, so forth and so on, if we want to think in degrees. All right, now if I look at multiples of pi over 3, or 60 degrees, well, if I take pi and I divide it into 3, that's going to be every 4th tick mark. So here's pi over 3. Here's 2 pi's over 3. And I go 4 more tick marks, I'm at 3 pi over 3, so forth and so on. This would be 4 pi over 3, 5 pi over 3, and then 6 pi over 3. And then last week we have our multiples of pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6. We're going to 4 pi over 6. This is going to be 5 pi over 6. 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Right, so now let's plot our points. At 0, we're at 0. At pi over 6, we're going to be at 1/2. So that would be right here. At pi over 4, well, it's the square root of 2 over 2. And the square root of 2 over 2, if we pop this into our calculator, just to get an idea where we're going to plot this, I'm going to do square root of 2. Divide that by 2, we get 0.7, so it's about equal to 0.7. So just for reference, that's going to be about equal to 0.7. So at pi over 4, we're at 0.7, that's 0.75, so it's a little bit below that. Pi over 3, we're at the square root of 3 over 2. So if we do square root of 3 and divide that by 2, we're at about 0.86, or almost at 0.9. So this is about 0.9. So here we're going to be at 0.9, which is way up here, very close to 1. When we hit pi over 2, we finally hit 1. Now notice the outputs repeat themselves. At 2 pi over 3, we're back here at 0.9-ish. At 3 pi over 4, we're at the square root of 2 over 2, which is down here. At 5 pi over 6, we're back at 1/2. And at pi, we're at 0. So this is the first part of the sine curve. It goes like this. It looks like a hill. If we keep plotting, at 7 pi over 6, we're going to be at -1/2. Then we're going to be at -0.7. Then we're going to be at -0.9. And then at 3 pi over 2, we're at -1. We're going to go back up to -0.9, -0.7. And then we're going to be at -1/2. And then we're going to be at 0. So we see this sort of symmetry The same shape now falls below the x-axis. Now that's only one wave. We could now look at angles beyond 2 pi, and we're just going to keep going around. So if we go to 2 pi and then we add 30 degrees, so if we do 390 degrees, we're going to be right back to here, which is 13 pi over 6. And we're going to be back up here. We're going to do this. It's going to be up here. And it's going to look like this, and it's going to continue forever. And likewise, in the negative direction, it's going to continue forever. So what we have going on here is what we call a periodic function. Okay? If we were to do this over and over again, this is what the graph would look like. So this is the graph between a little bit beyond 15 to negative 15. This is the graph of y equals the sine of x. Right, so notice it starts at the origin. If we start here, it goes up and then it goes down. And then this shape just keeps repeating itself over and over, and it repeats from the left to the right. We say that the sine curve is periodic with period 2 pi. So we say y equals the sine of x is periodic with period 2 pi, meaning it repeats itself every 2 pi. Then it repeats itself again, 2 pi, repeats itself to the left, 2 pi, forever and ever. How high and how low it goes is called the amplitude. So let's be careful here. Let's look at just one sine wave. One wave of the sine curve looks like this, and this is the shape that's going to repeat itself infinitely. Periodic with period 2 pi. And the amplitude is not the entire height, but it's from the center up and from the center down. So the amplitude of this is said to be 1, because we go up 1 and we go up down 1 from the center. So we say that the sine wave is periodic with period 1, periodic with period 2 pi, and amplitude 1. It goes up 1 unit from the center and down 1 unit from the center. So that's our basic sine curve. So what happens when we jack it up a little bit? Let's look at the one period of y equals a constant, times sine of bx, a constant, times x. So what changes is the amplitude in the period, but the shape does not change. We still have a hill followed by the same size valley. The amplitude from the center to the top is going to be the absolute value of the leading coefficient. So the amplitude is equal to a. And then the period, which was 2 pi, but that was prior to the b being in here, the period now becomes 2 pi over b. So it repeats itself every 2 pi over b, where here b was 1, so it took a period of 2 pi to repeat itself. Here it depends on the value of the coefficient inside there. So we have 5 major points of interest when we're plotting the sine curve. I always start with where it starts, where it crosses, and where it ends, and then its high point and its low point. So if you can locate those 5 points, you can very easily graph the sine functions. So I say graph 2 periods of y equals 2 sine of 6x. So I identified the amplitude is determined by this number right here. So the amplitude is equal to 2. And the period, how long it's going to take to make one complete wave, is 2 pi over 6. And 2 pi over 6 simplified is pi over 3. So this distance from here to here, the width is going to be pi over 3, and the height is going to go from 0 to 2 and 0 to negative 2. So what I do, I look at my axes. I'm going to go 2 up. I'm going to go 2 down. And then I'm going to go over a distance of pi over 3. So here there's no tick marks on the axes. So I can put them wherever I want, but I'm going to need to divide this width, which is pi over 3, into 4 equal parts. So I'm going to use 4. Here, actually, I'm going to use 8 because I think it'll be easier to see. I'm going to call 1, 2, 3, 4, 5, 6, 7, 8. I'm going to call this pi over 3. So I imagine, this is not part of the graph, but I just imagine this rectangle of height 2, the bottom of the rectangle is at -2, and extends from 0 to pi over 3. And then I plot these 5 points inside that rectangle. They are evenly spaced. So halfway in between, right here, is where it's going to cross. That's that point. It starts in the middle and ends in the middle of the box. Halfway between the first 2 dots is where it reaches its high point. Halfway between the second 2 dots is where it reaches its low point. So now if we put the values on the axes, this is where it gets a little challenging. Well, halfway between 0 and pi over 3, well, half of pi over 3 is pi over 6. 1/2 times pi over 3 is pi over 6. So it crosses at pi over 6. If I go halfway between 0 and pi over 6, 1/2 of pi over 6 is pi over 12. What would this point be? Well, now that I have the distance from the first point to the second point, the horizontal distance, I can count in these units. 1 pi over 12, 2 pi over 12, 3 pi over 12, which is pi over 4, and that's going to be 4 pi over 12, which is pi over 3. And I have enough information here to draw one period. So the sine curve is going to start at 0, 0. It's going to go up, make a hill, come down, cross at pi over 6, bottom out at pi over 4, and end at pi over 3. Now that's only one period, so we want to do one more. So I'm literally going to take this box up and make a carbon copy of it right next to it. So I chose my box to be 8 tick marks wide. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 2 units. Here. So I know at the first tick, so I'm treating this as a whole new graph. Right here, it starts at the middle of the box, crosses halfway, and ends at the middle of the box. In between the start of the box and the first and the midpoint, it's going to peak at the top. In between the midpoint and the end, it's going to bottom out. So I know that this is what it's going to look like. There we go. That is 2 periods. Now I could have gone in this direction 8 units, or pi over 3, but 8 blocks. So 1, 2, 3, 4, 5, 6, 7, 8. And I could have done the same thing, and I could have drawn 1 period on each side of the y-axis. Starts here, crosses in the middle, ends here, high point, low point. And then we could have just drawn it like this. Okay. Then we're going to put little arrows on here indicating that this continues forever. So this would be the graph of y equals 2 sine of 6x. So previously it took a whole 2 pi to repeat 1 period. Now it's only taking pi over 3. So the larger the number in here, the quicker this thing repeats itself. So let's just try to identify a few more of these key points. Again, once you have your period from pi over 3, you cut it in half. That's how I got pi over 6. And then halfway between 0 and pi over 6 was pi over 12. And then I count by pi over 12s. 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12. This point's going to be 5 pi over 12. This point's going to be 6 pi over 12, which is pi over 2. 7 pi over 12. And then 8 pi over 12, which is 2 pi over 3. So it started at 1 period was pi over 3, and it repeated again and finished at 2 pi over 3. If we go in the negative direction, pi over 12 from here to here, so from here to here would be negative pi over 12. And then would be that point, and then this point would be negative pi over 6. 1 pi over 12, 2 pi over 12, 3 pi over 12s would be negative pi over 4. Oops, I lost one. Negative pi over 12 would be the low point. It's going to cross at pi over 6. Right? And it's going to reach its negative pi over 4. And then that one's going to be negative pi over 3. There we go. All right. So it's kind of a clever way to do it. If you have a different way to do it, that's fine, as long as you graph it clearly. Let's just answer a couple questions. The domain of the sine function, unless otherwise stated, is all real numbers. If we look at the graph, we see that the graph is completely sandwiched between 2 and negative 2. So it bottoms out at negative 2, and it maxes out at positive 2. Inclusive, because this point has output 2, that point has output negative 2. All right, let's try another one. Let's graph 2 periods of the sine y equal, or the curve y equals negative 3 sine of 1/2 x. So we want to look at these values right here. This is going to tell us the amplitude, how high it's going to go, and this is going to tell us how low it's going to go. Notice this has a negative. So the amplitude is always the absolute value of the coefficient. So it's going to go between 3 and negative 3, but we say the amplitude is positive 3. The period, on the other hand, is 2 pi over 1/2, which is equal to 4 pi. So this is a smaller number. It's going to be spread out. Okay. Now note, this was one sine curve. This is going to be a negative sine curve. So just like in all our transformations, a negative out front just flips it over. So it's going to be the same shape, but instead of starting in the middle and going up, we're going to start in the middle and go down. All right, so the period is 4 pi, so I'm just going to do, it says 2 periods. 1, 2, 3, 4. I didn't leave very much room. 1, 2, 3. Let's call this 4 pi. Okay, and then I'm going to go up to 3 and down to negative 3. And then I'm going to imagine sandwiching one sine curve into this box nice and tightly. So the sine, if we draw our box, our imaginary box, it's not part of the graph, but it's going to help us draw the graph. The sine always starts in the center of the box at the origin. At the first point, it's going to reach its low point, cross in the middle. Third point, it's going to reach its high point. This time we went down first because of the negative 3. So these are our 5 points that we need. It's going to look like this. So that is one period of y equals negative 3 sine of 1/2. So let's just identify these points where they cross. Well, if the period is 0 to 4 pi, halfway is going to be half of 4 pi, which is 2 pi. Halfway between 0 and 2 pi is half of 2 pi, which is a pi. So now at every tick mark we've got, at every point we are going pi units. So 1 pi, 2 pi, this is going to be 3 pi, 4 pi. Now we want to graph 2 periods, so we want to make sure we graph another one. I gave myself 8 units. 1, 2, 3, 4, 5, 6, 7, 8. So here's 8 pi. And here's my little rectangle. If I look at this shape, start here. It's negative, or we're going to go halfway. 1, 2, 3, 4. All right, we're going to go halfway is where it's going to cross, and it's going to end. So at the first quarter, we're going to go down. Second quarter, halfway, we cross again. Third quarter, we're going to max out, and then we're going to end here. So it looks like this. And we're going to use arrows to indicate that it continues in this pattern forever. So we have 1 pi, 2 pi, 3 pi, 4 pi. It's going to bottom out at 5 pi. It's going to cross at 6 pi. It's going to max out here at 7 pi. And then it's going to cross again at 8 pi. So looking at this, the domain of y equals negative 3 sine 1/2 x is all real numbers. The domain of the sine function, unless otherwise stated, is always all real numbers. And the range is, well, it bottoms out at negative 3, and the max it goes is 3. So the range is dependent on the amplitude. So negative 3 to 3. All right, so let's just see if we can generalize this. here's a sine wave. This is 1 period. It maxes out at P, and it reaches its low point at negative P, or flipped if it's negative. 1 period is going to be 2 pi over Q. Right. Halfway here is going to be half of that, which would be pi over Q. Halfway in between there would be pi over 2Q. 1/2 pi, 1 pi. This is going to be 3 pi over 2Q. So that can be a little tricky. I think it's easier just to do it this way. Now let's take a look at the cosine. Very similar to the sine. The cosine has the same outputs as the sine, but just assigned different inputs. So we have all the outputs of the cosine. Okay. So if I was to graph this, if we know, again, it doesn't exceed 1 or go below -1, that's the plain old cosine. No coefficient out front. The coefficient out front is 1, and the coefficient inside touching the variable is 1 also. It does a cycle of 2 pi. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 pi. All right, here's pi. Here's 0. So let's do pi over 2. I won't go into quite the detail with this. 3 pi over 2. Right, and let's just plot these points. At 0, the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is back to 1. Now if we put in a couple more, we'll see that it's not a V shape. That the cosine, if you plot a few more of those and squish them in, you'll see that it follows the same hill and valley pattern as the sine. So if I go out to 4 pi, and this is 3 pi, we're going to see that it crosses here. At 3 pi, it's -1. It's going to cross here, and at 4 pi, we're going to be back at the same value as 2 pi. And it looks like this. So when we draw 2 periods of the cosine curve, we see that it's very similar to the sine curve. It's actually just the sine curve, right, shifted. So we call this, starting when x equals 0, 1 period of the cosine wave. And we pick that shape up and we repeat it over and over. If we look at this guy, this is the graph of the cosine. Right, notice it starts up top, where the sine curve crosses through the origin. This one starts up here, it starts out at 1. So this is what one wave of the cosine function looks like. We're going to put an infinite set of these together. So the period of regular y equals cosine of 2x is 2 pi. The amplitude, it also goes between 1 and -1. So the domain would be all real numbers, and the range would be from -1 to 1. So let's just write that in there. So it's the same domain and range. All right, so that's not all that interesting. So what happens when we put coefficients out front? The same thing happens to the cosine that happened to the sine. A is going to determine the amplitude, and B is going to determine how quickly this repeats itself. So the amplitude the absolute value of the number out front. The amplitude, it goes down that distance too. And the period is the same concept as the sine. It's 2 pi divided by whatever that number is out front. The larger that number is, the quicker the cycles repeat. So let's graph two periods of y equals 1/2 cosine 5x. So the amplitude is 1/2, and the period is going to be 2 pi over 5. So this gets a little tricky. So what I do is I'm going to go up 1/2, and I'm just putting 1/2 here just so we can see it better. So I'm going to go up 2 tick marks and call that 1/2. And then I always go over multiples of 4. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to call this my period. So I'm just going to do one period first, 2 pi over 5. And I like breaking it up into multiples of 4 because I want to break this box up into fourths. So here's one box that we're going to fit this entire shape in. And our points of interest are the upper left corner, the upper right corner. Halfway through, it bottoms out, and 1/4 of the way through it crosses, and 3/4 of the way it crosses. So if I divide this in half, and then divide it in half again and again, I'm going to identify those points momentarily, but this time we're squeezing this shape in here. So for the cosine, we start in the upper left-hand corner. At the first fourth, we cross the x-axis. The second fourth, we bottom out. Third fourth, we cross the x-axis. And at the right, we go back up to the corner, to the top. So this is one cosine wave. Let's just identify. Now these get tricky. Now remember, from here to here is 2 pi over 5. So halfway in between there is half of this. So half of 2 pi over 5 is pi over 5. Now I go halfway between 0 and pi over 5. Well, 1/2 times pi over 5 is pi over 10. Once I have this one, it's going to help me find the third one. So now every fourth has distance pi over 10. 1 pi over 10, 2 pi over 10, which is pi over 5. So 1 pi over 10, 2 pi over 10. This is going to be 3 pi over 10. And that is 4 pi over 10 simplified. So that's one period. So now I can draw another one to the left or another one to the right. I'm just going to, for simplicity, draw it to the right. 1, 2, 3, 4, 5, 6, 7, 8. So I had drawn that one 8 boxes long. So I'm going to do this one 8 boxes long. So if I go out another 2 pi over 5, so I double that, we're going to be at 4 pi over 5. And if I divide that into half, and then each of those in half again, all right, so I have a whole new box, and in my box I start in the upper left-hand corner, which is already there for us. The first quarter we cross, third quarter we bottom out, fourth quarter we cross, and we end at the top. So it's going to look like this. Ooh, beautiful. We're going to put an arrow indicating that it's going to do that forever. So again, something happens at each pi over 10. 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. So this is going to be 5 pi over 10, which is pi over 2. 5 pi over 10, 6 pi over 10, which is 3 pi over 5. 7 pi over 10, which is 7 pi over 10. And then 8 pi over 10 is where our second period ends, and we're at 4 pi over 5. All right, so domain of cosine, just like the sine, is all real numbers unless otherwise stated. The range, well, it bottoms out at -1/2 and maxes out at 1/2. So the range, like for the cosine, like the sine, depends on the amplitude. Now again, we have to be careful. So let's look at the next example. When we have a negative, one cosine wave starts like this, goes down and ends at the top. The negative is just going to flip it over. It's going to start at the bottom and end at the bottom. So this would be the cosine, and this would be the negative cosine. So it just flips it. So the amplitude is equal to 6, and the period is equal to 2 pi over 3. So I'm going to go up 6. Well, I didn't leave myself 6 tick marks, so I'm actually going to go up just 3 and call that 6. 1, 2, 3. Call that -6. So each one of these we have a in between will be a unit of 1. Right, and then I'm going to count out 8. 1, 2, 3, 4, 5, 6, 7, 8. And I choose a multiple of 4. And I put my period here. And I imagine this little box. And I choose a multiple of 4. Because then that way I can cut it in half nicely. And half of 2 pi over 3, well, 1/2 times 2 pi over 3 is pi over 3. And I'm going to go halfway in between there and there. Now this time we're going to be doing this shape. It's the negative cosine. So instead of starting in the top left, we're going to start in the bottom left. Cross at the first tick mark. We're going to max out at the second tick mark. Cross at the third and back at the bottom. So here is one wave of -6 cosine 3x. And then these values, well, halfway between 0 and 2 pi over 3 was pi over 3. Halfway between 0 and pi over 3, well, half of pi over 3 is pi over 6. And now I just count by pi over 6's. 1 pi over 6, 2 pi over 6, which is pi over 3. 3 pi over 6, well, 3 pi over 6 is pi over 2. And that's 4 pi over 6, which is 2 pi over 3. So I'm going to do one more. 1, 2, 3, 4, 5, 6, 7. I'm going to go out 8. I'm going to go out here. We're going to double the period. 4 pi over 3. Halfway in between. Halfway, halfway. So here's my box. It's an upside down cosine curve. So we start in the bottom left corner. First tick mark we cross. Second tick mark we max out. Third tick mark we cross. We bottom out. And we're just going to connect that, and you can see the wave starting to happen. I'm going to indicate with arrows that this continues on forever. I'm going to count by pi over 6's. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This would be 5 pi over 6. 6 pi over 6. 7 pi over 6. And 8 pi over 6. Okay. Lastly, let's just write the domain and the range. The domain of the cosine is all real numbers. The range of y equals -6 cosine of 3x is bottoms out at -6, maxes out at 6. So just to generalize, I'm not a fan of this, but I'll put it in there anyway. 1 period of the cosine. Right? So if we have y equals p cosine qx, it's going to max out at p, bottom out at -p. And right here, this is going to be 2 pi over whatever that value q is. Halfway in between is just going to be pi over q. Halfway in between there would be pi over 2q, because half of that. And then this would be 1 pi over 2q, this would be 3 pi over 2q's. All right, have fun with that. See you later.